Hey everyone, what we're going to do here is solve for x in our square root function. And we've got something a little bit tricky here because we have an x value on the outside of square roots on the other side of the equation, and we also have an x value that's inside of this radical. So we've got a couple x's floating around in this equation. We want to get after this thing. And I would say the thing that's impeding us the most for solving for x is probably this square root that's hanging out over this binomial here. So if we want to get after these x values, the first thing we want to do is get rid of this radical. So if this is a square root, we want to perform the opposite operation. So the opposite of square rooting is squaring. So we're going to take both sides and square the entire equation, or the entire side of the equation. So once I square my right side, these actually will cancel out. The square of a square root is that they are opposite functions of each other. So on the left, I'm going to have an x squared. That's what I get when I square my x. And on the right, I just have my 3x plus 10 left over. So now it looks like we have a quadratic. How do I know this? Because my degree of this equation is 2. So now I got to remember, okay, how do I solve quadratic equations? Well, what I'm going to do is first I'm going to get everything to one side. And I'm going to subtract 3x, and I'm going to subtract 10. So these go away, and I'm going to have an x squared minus 3x minus 10 is equal to 0. So there's all different kinds of ways that we can solve these quadratics, and I think that I can factor this one. So I'm going to solve this by factoring. So I can factor this as x minus 5 times x plus 2. That is equal to 0. So now we're going to drop a t on this guy, split my factors, and set each factor equal to 0. So over on the left, I'm going to get an x equals 5, and on the right, I'm going to get an x equals negative 2. So this is all well and good. We've done a whole bunch of good solving here. We solved our quadratic, but there's something that is a little bit different than the last time we were solving quadratics. We have to remember to check for extraneous solutions. And the reason we have to do that is because we're dealing with a square root function. Most of the functions that you've seen so far involve domains of all real numbers, meaning you could plug in any number for x, you're not going to get any trouble or anything like that. But now with our square root functions, we're limiting our domain. That means that there are going to be some x values that we cannot use inside of this radical. So that's why we have to check both of these, that they work out here. So let's see what happens when we test our values. Let's test first x equals 5. So if we plug in 5 into our original equation, we're going to have 5 equals, you know what I'm going to do? I'm going to kind of partition this off. So 5 is going to equal the square root of 3 times 5 plus 10. So let's see, I'm going to kind of jump a couple steps here. 5 is going to equal the square root of, this is 45 plus 10, and that's going to be 55. Wait a second. Looks like something's happened here. Oh, this shouldn't be 15. This should be 5. That's why. Let's try that again. So this is going to be 3 times 5 plus 10. That works better now. So this is 15 plus 10, or a 25. And the square root of 25 is 5. This guy works out all right. Whew, that was close. All right, let's try x equals negative 2. Next. So I've got negative 2 equals the square root of 3 times negative 2 plus 10. Already I'm seeing something kind of fishy here. I have this radical that is equal to a negative value, and I don't really like that so much. So this is going to be negative 2 equals the square root of, here's negative 6 plus 10, which is 4. So the square root of 4 is actually equal to 2, not equal to negative 2. This is going to be extraneous. I'm going to get rid of this solution, and my only one true solution is x equals 5.